one of the most important concepts that is from which questions usually come in JEE Advanced. That concept is rolling. So what is basically rolling? Rolling is basically when a body has translational velocity of center of mass and then there is an angular velocity omega. So there is a translation and there is rotation involved. So if the body is having translation, what will be its translational kinetic energy? It's going to be half m VCM square, and what will be its rotational kinetic energy? It will be half ICM, which is the moment of inertia about the center of mass, into omega square. So the combined kinetic energy of the body is translational kinetic energy plus rotational kinetic energy. And in case of pure rolling, the velocity of center of mass and r omega must be equal, which implies that if the ground is at rest, so the net velocity at the point of contact with the ground, which is VA, will become 0, because VCM direction is in the forward direction, VCM, center of mass velocity, and the r omega direction is in the reverse direction. So they will cancel out because of this condition. So this point, which is the bottommost point, it will be at rest. It will be at rest. So that means that point is at rest and friction is not going to perform any work. So this means the work done by friction is going to be 0. So even though non-conservative force like friction is present in case of rolling, but because the work done by friction is 0, that means you can apply U plus K equal to constant, the conservation of energy concept in case of pure rolling. So this year's JEE Advanced question was asked from this particular chapter. So we'll discuss that question here. So the question is, I think I have the question. There are 2 questions asked, so I'm going to discuss the first question that I've got, which is question number 3. So the question is saying, see, that there is a tabletop and on the tabletop there is a solid cylinder. And the solid cylinder, center of mass has velocity V0. Now the value of V0 is given in the problem as root under GR by 3. Okay. So this is a solid cylinder. Now what is a solid cylinder moment of inertia? It is mr square by 2. Okay. Here G is the accident. Okay. At the moment when the cylinder loses contact with the surface due to rotation around the corner, the speed of its center of mass that we have to calculate. So this rolling object is going to lose contact with the edge of the table. So when this rolling object has come here at the edge, let us assume that its velocity is V0 at that time and the value of V0 is given and it is rotating, right? So we can apply energy conservation between this point where the phenomenon of actually losing contact with the edge of the table starts. Now when it is on the verge of losing contact, how the free body diagram will look like. So this point, if I call it point A, the point A will now come momentarily at rest and this body, the rotating object, which is a cylinder here, is going to get toppled over at the edge. So wherever it gets toppled at the edge, there normal reaction will become 0, because normal reaction equal to 0 is the condition of losing contact with the surface. So if I draw the free body diagram now, A is at rest, the bottommost point is at rest, and say the center of mass has come somewhere here. So I'll zoom into this. Let me draw it like this. So this is the center of mass position, and center of mass obviously has rotated by an angle theta with respect to vertical. So the center of mass was initially where? It was initially here, the red dot. This is that position here. This is the red dot. Okay. So this is the initial position where the phenomenon of losing contact starts. And here at this final moment, it actually happens. So this means the normal reaction here at this particular point with respect to A will become how much? 0. So center of mass, let us assume at this point has got velocity V. So what will be the pseudo force value? It's going to be mv square by r, and the component of gravity towards this point, you can see this is the mg acting vertically downward. If this angle is theta, this is also going to be theta, and what will be the component of gravity towards point A? It is going to be mg cos theta. So for this cylinder to lose contact at point A, mv square by r, which is a centrifugal force, must be equal to mg cos theta. So this is the equation 1. For this condition, the normal deviation becomes 0. And also, as I discussed at the very beginning, that for rolling object, u plus k, the summation of potential energy and kinetic energy is constant, so we can use this equation also. So this is the initial position. So at initial position, I am taking this line, the red line, as the reference frame. So the table surface is the reference frame. So what is the height of the center of mass at the point A? It is the radius r, right? So what is its potential energy at point A? It is going to be mgr, because the reference frame is the table surface. Now also at this point, the body is in rolling. So what will be its kinetic energy? It is half m v naught square plus half ICM, moment of inertia of a solid cylinder, is mr square by 2 into omega square. So I'll write it as omega naught because it is given v naught, so I'll take it as omega naught. This is equal to, now when it is getting rolled over and on the verge of losing contact, at that point mv square by r and mg cos theta must be equal, right? And this point, the point where it is on the verge of losing contact, I'll assume that center of mass has rotated by an angle theta and its velocity is v, and also the body is rolling, so I'll take the angular velocity at the final position at the point A as omega. Now v equal to r omega is still valid because at point A the body is still rolling. So what will be its final energy? So final energy means I need this height. Which height? The height from the reference frame where the center of mass is present. So this means I need this height. So from simple geometry, I can easily find out this red line, the height of the center of mass from the reference line is how much? It is r cos theta. So the potential energy is mg r cos theta, and the kinetic energy is half mv square plus half mr square by 2 into omega square. So please check whether this equation is understood or not. I'll rewrite it again. So this is the kinetic energy, translation plus rotation included, and this is the potential energy initially. So when it has come to the edge, the topple getting lost, getting the contact lost has not yet happened, and at this point the contact loss is actually happening, right? Now because the moment of inertia is mr square by 2, so if I solve this, kinetic energy half mv square plus half mr square by 2 into omega square, but remember in case of rolling, v equal to how much? It is r omega. So simple calculation, 1 by 2 into 1 by 2 becomes 1 by 4, and this becomes mv square. So half mv square plus 1 by 4 mv square, this gives you 3 by 4 mv square, right? So what is the equation now? mgr plus 3 by 4 m v naught square is equal to mgr cos theta plus mv square 3 mv square by 4. I hope the equation is understood. Now put the value of v naught. So what is the value of v naught? It is given in this problem here. It is root under gr by 3. So if I substitute the value, what I am going to get? So I'll just erase this diagram and let us just do the calculation. So I'm going to get mgr plus 3 by 4 m v naught square, which is gr by 3, root under gr by 3 whole square, so gr by 3. 3 cancels out, and this gives me mgr cos theta plus 3 by 4 mv square. The target is to calculate this speed, the speed of the center of mass. So this speed is my target, because that is what the question is asking, the speed of its center of mass when it is about to lose contact, right? So what I'm going to get, mgr by 4 plus mgr, so this gives me 5 mgr by 4 is equal to mgr cos theta plus 3 by 4 mv square. But we already have solved that when this cylinder will be on the verge of losing contact, the pseudo force is mv square by r, must be equal to the component of gravity, which is mg cos theta, right? So mv square by r is equal to, this angle is theta, and this is the gravity mg, so this angle is also theta, mg cos theta. So here you can see easily that there is one mg cos theta present in this part, so I can replace that mg cos theta by mv square by r. So what I am going to get now, I am going to get mv square by r into r, that means I am getting 1 mv square plus 3 by 4 mv square. So this gives me 7 by 4 mv square is equal to 5 by 4 mgr. Target is to calculate this v. So cancel the mass. So what is the value of v that I am going to get? The value of v is coming as, also cancel 4, it is coming 5 by 7 gr root under. So the answer that I am going to get is option B. So I'll just rewrite, v is equal to root under 5 gr by 7. So I hope that you understood the solution and you liked it, and I'll make more such videos in future. Thank you for watching. Tata.